If the conjugates will cancel, minus 5 there, because I have a positive times a negative, and square root of 5 is 5. So if I add those together, I get negative 4. So my product ends up, if I reduce it down to negative 1/4. So an example of a quadratic equation then, with these roots, would be x squared minus the sum of the roots, which is 1/2 with the x, plus the product of the roots, which is actually negative 1/4. So I could have just wrote that with a minus sign there. Now sometimes they'll ask you to find a quadratic equation with integer coefficients. So this is a great quadratic equation right here, but it does not have integer coefficients. So if they asked me to do that, I could just multiply each one by 4. So a quadratic equation with these roots with integer coefficients would be 4x squared minus 2x minus 1 equal to 0. So there is my quadratic equation with integer roots, with integer coefficients, or the other one with a coefficient of 1 on the x squared term. Okay, let's see what's next. The next one, I asked you to solve these 3 problems using the quadratic equation. The quadratic formula. Okay. So could you solve these using the quadratic formula? So I'll give you a few minutes to solve those. Okay, on the first one, A is 4, B is negative 12, C is 9, so x would equal 12 plus minus 144 minus 4 times 9, which happens to be 144, all over 2 times A. So I get negative 12 plus or minus the square root of 0 over 8. Square root of 0 is 0. So if I take 12 plus 0, or if I take 12 minus 0, I'm still going to get 12 over 8, or I could reduce that to 3/2 or 1.5. Now this solution, we only got one answer. Usually when we use the quadratic formula, we get 2 answers because we're adding and subtracting the square root of a number. But this time, since the square root was 0, we only got one solution, one real solution. And this solution is called a double root. And one reason is because if we take 12 plus 0 over 8, 12 minus 0 over 8, we get the same solution twice. So it is called a double root when you only get one solution. Your next one, A was 1, B was 1, C was 2, so x equals negative 1, plus or minus the square root of 1 squared is 1, minus 4 times A times C, which is 8, all over 2 times A. We ended up with negative 1, plus or minus the square root of negative 7 over 2. And if we're in the real number system, there is no square root of a negative number. So this problem, since we can't take the square root of a negative number in the real number system, this one has no real solutions. And the last one, A is 1, B is 3, C is negative 5. So x equals negative 8 plus or minus the square root of, that would give you 9 minus 4 times 1 times negative 5 is negative 20. So that's a plus plus. All over 2 times A. So I end up with negative 3 plus or minus the square root of 29 all over 2. So this one ended up with 2 real solutions, like we've seen on most of our problems we've been doing. So So negative 3 plus the square root of 29 over 2, and negative 3 minus the square root of 29 over 2. So the reason I wanted to look at these three is I wanted you to look at the graphs of them. So on the next slide, I have the graphs of these three equations. So the first one was when we had one root, the double root. So the double root, you have one distinct solution, which was right there, which was at R, that was at 1.5, and it only has one x-intercept. So double roots are when your graph of your quadratic equation or your parabola only touches the x-axis in one location. In the second one, we didn't have any real number solutions. And if you look at the graph, the parabola never touches the x-axis, and there are no x-intercepts. So if it has no real number solutions, it'll have no x-intercepts. And our last one had two distinct real number solutions, so it has two x-intercepts. And those x-intercepts were at the two solutions of the equation. So double root has one x-intercept, no real solution, none, and one with two distinct solutions has two x-intercepts. So the way that we can determine how many solutions a quadratic equation will have is all based on something called the discriminant. And the discriminant is the part of the quadratic formula that's under the square root symbol, because that's the part that determines the number of solutions. So if b squared minus 4ac is greater than 0, then the equation has two distinct roots. We found out if it was equal to 0, then the equation had exactly one real root. And that was when it was a double root, or sometimes they call that a multiplicity of 2. But if the discriminant is less than 0, then there were no real solutions and no x-intercepts. Okay. On the next one then. Here, I just would like you to compute the discriminant and then tell me how many solutions there will be. Will there be two distinct real solutions, one solution, or no real solutions at all? So on this problem, I only asked you how many solutions there were. I didn't care what the solutions technically were. So we're only going to use the discriminant test to find the number of solutions. And the discriminant is b squared minus 4ac. So if I do 1 squared minus 4 times 1 times negative 1, I get 1 plus 4. I get a discriminant of 5. And since 5 is greater than 0, that tells me that my quadratic equation will have two distinct real roots. On this last problem, I want you to try a little bit different way of doing this. It says find a value for k such that this quadratic equation has one real solution, exactly one real solution. So how could we try to find what value for k would make this quadratic equation have only one real solution? So try that. So, using the discriminant, b squared minus 4ac, we know we have exactly one real solution when that is equal to 0. So, in the problem, a is 1, b is root 2, and c is k. So, subbing those in, we have the square root of 2 squared minus 4 times 1 times k. We want this to equal 0. So square root of 2 squared is 2. So minus 4k is equal to 0. So if I add over the 4k, 2 is equal equal to 4k. Dividing by 4 gives me a k of 1/2. So when k is 1/2, this quadratic equation will have exactly one real solution and one x-intercept. So there's your lesson on quadratics.